Now let's consider the ionic bond. Ionic bonds occur between two atoms, where one of the atoms has gained an electron, the other atom has lost an electron. At the core of this is the octet rule. If we look at this example of sodium, we can see that the first, second and third shells all have electrons, but the first and second shells are completely full. The third shell is partially full. So the outer shell is the third shell, and the valence electrons are 1. Octet rule tells us that to gain greater stability, we can either lose 1 electron or gain 7 electrons. Now we need to go to the nearest group 8 element, so that will be losing 1 electron. We can see that then we have the same number of electrons as we see in neon. But notice the number of protons has stayed the same. So we have gone from having 11 electrons and 11 protons to having 10 electrons but still 11 protons. So the overall charge has changed from being neutral to being 1+. When we do this, we create a cation. Now this is not only true of sodium, but of all alkali metals. They all want to lose 1 electron to gain extra stability, and they do it by making bonds. Now let's look at an opposite case to sodium. Here's an example of chlorine. Again, we see there are electrons present in the first, second and third shells, and yet again we can see the first and second shells are filled. The third shell is partially filled, so again the outer shell is the third shell. However, the number of valence electrons, instead of being 1 as it was in sodium, are now 7 for chlorine. So according to the octet rule, we have two choices available. We can either lose 7 electrons, or we can gain 1 electron to achieve a group 8 number of electrons. Now, we also know from the octet rule that we must go to the nearest group 8 element. And so it's easier, that's to say requires less energy, to gain 1 electron than it would be to lose 7. So chlorine would like to gain 1 electron. Now, if we count the number of electrons, we'll see we have the same number as we find in argon. Now we need to think about the number of protons. As we look at chlorine and how it has changed, the number of protons have stayed exactly the same. So we can see that we start off with having 17 protons and 17 electrons. And after the change, we have still 17 protons, but now 18 electrons. So the overall charge of the atom has changed from being neutral to being negative. And we call this an anion. Chlorine is a halogen, and all halogens have 7 electrons in their outer shell, so behave in a similar way that they seek 1 more electron to gain extra stability. And they do this through making ionic bonds. Here we encounter sodium that would very much like to give away 1 electron. And we have 1 atom of chlorine that would very much like to gain 1 electron. They seem like a perfect match. And that is exactly what happens. Sodium loses the electron and gives it to chlorine. By doing so, sodium becomes 1+ and chlorine becomes 1-. Here we see the whole process, viewing all the electrons. The sodium gets rid of an electron, becoming 1+, and chlorine takes the same electron, becoming 1-. Note, nothing's going on in those inner shells. Only valence electrons in the outer shells are moving between atoms. This results in an electrostatic attraction between the two atoms that we call an ionic bond.